Here's a set of parametric equations describing a plane curve. So let's see if you and I can't just dive in here and by brute force remove the parameter to see what the relationship is between x and y without having that parameter t. So I do think the first equation says that the cosine of t is equal to x over a, and I can even take it one step further, isolate t completely if you like. And now the second equation is telling me the following, that y is equal to b times the sine of t, where t is just the inverse cosine of x over a. But to say that t is equal to the inverse cosine of that fraction, or better yet, just to say this, means that if I were to embed t into a right triangle as one of its acute angles, it simply means the ratio of this side to this side is x to a, which means the length of this vertical leg is this. And so I now have that y is equal to b times the sine of that angle, which is that over that. So now let me clean up. I will get rid of fractions. Allow me to square both sides. Let me bring all the terms involved in the variables to the left-hand side. And one last little effort. Let me divide both sides by that. And clearly you recognize that as a standard form for the equation of an ellipse. But everybody, I might have wasted a little bit of time. I expect you to be able to remember the parameter as such. Is important. But I have to confess, this example is a bit contrived. I just happen to know an easier way of getting that relationship. And the easier way is just recalling the Pythagorean identity, well, the first Pythagorean identity from trigonometry, which says this. It's just that another name for the cosine squared of t is x squared over a squared. And here's another name for the second term. I avoided all that work, but again, it's because the example's a bit contrived. I know a relationship between sine and cosine, and that is one of the most important relationships. So either way you look at it, I want to point out that how you trace the curve out depends on what these two equations have involved with them. And I want you to trace out that ellipse in such a way that t ranges from 0 on up. So t ranges from 0 up to increasing this without bound, if I said that correctly. So everybody, we know what the graph looks like. It's an ellipse. 2x intercepts at plus or minus a comma 0. 2y intercepts at 0 comma plus or minus b. However, notice when t is equal to 0, x is a, y is 0. So there's my first point. Now, at pi has, I should rotate 1/4 of the way through the entire graph. But at pi has, s becomes 0, y becomes positive b. And so I know I start here and I rotate in this direction. There's my initial point. Now notice how this set of parametric equations is going to describe exactly the same curve. It's just that I might have different orientation, meaning I might rotate in the clockwise direction, or I might even start at a different point. Let's see what happens. If t is equal to 0, certainly I get that x is 0, y is equal to a. So, did I say y is equal to a? I think I misspoke, didn't I? Shoot. All right, you guys, hold on a minute. There's nothing wrong with these examples, but I want them to be more related than this. So humor me and allow me to change these coefficients real quick. If you allow me to change like that, this way the curve's not going to change in terms of what its x and y intercepts are. But, like I said, t is equal to 0. Now x is 0, y is b. And so I start at this y-intercept 0, comma b, instead of that x-intercept a, comma 0. So that may be my starting point. I'll make a big dot. Now to show the orientation, again, just like I did before, I'll rotate 1/4 rotation by evaluating x and y when t is equal to pi halves. Does that give me x is a? Sorry, I'm a little slow. And y is 0. So I get to the x-intercept right here, which means I'm rotating in this direction. So I did change both the initial point and the orientation of the curve. And how about very quickly just changing the sign of the x value, the x coordinate. Notice I'm still going to start at point 0, comma b. Those are the coordinates of the points. Those are the coordinates of the point I generate when t is equal to 0. However, if t is equal to pi halves, notice how x actually negative a, y is going to be 0. Notice that I'm rotating in this direction. I'll show my orientation. Big dot for initial point.